Hi everyone, Senan this side, and in this video we are going to continue our linked list playlist. So in this we have already implemented three types of insertion, two types of deletion, head and tail, and in this video we are going to see the more generalized case, that deletion at any position. So we've discussed this in the theory, so be sure to check that out. And for this code I have distributed the code into three parts. On the left, the header file, which would include the declaration. On this would be including the definition, and the main CPP is where we are going to test our code. So let's get started. Let's start by defining the signature, delete at position, and in this it would take an integer position, and yep, that's it. Now let's write the signature and let's talk this through. How would we actually write this code? So void, and first we need to tell the file that where are we actually getting this function from. So linked list is the class where we are getting this function, linked list, and the function name is delete at position, which would take integer position. And yeah, so how do we go about this? First, a couple of things. Always when you are deleting a node, any node, either it could tree or something, even in linked list, first you check the very first thing, which is if the head is equal to null or not. If head is null, you just return. Another case would be if, so I'm taking the position as 1 based indexing, so you can modify this accordingly to 0 based indexing, but 1 was good for the explanation part, so I'm going with that itself. So, or if position is less than equal to 0, in that case as well I would return. So technically I'm assuming that the person that would be giving this argument would be sane enough to give the positive integer, but let's say for some reason he gives a negative value or the 0 value, we would be returning. Now the case where if position is actually equal to 1, what does that mean? If I mean the position is 1, that means it's delete at head, right? So what I could do, like you see this function, right? Delete at head. I can either just copy paste the same function, right? Or what I could do is just call this function, but I'll just take this code, copy this and paste it here. And let's see, if position is 1, my new head would be heads next, right? Then we delete the head, what is already there. Now we assign head to this new head, and then we return. So this is the case where position is 1. Now for the remaining cases, as we discussed in the theory video, we have to jump position -2 times, right? So let's declare a node star temp, which would be pointing to head. Now we have to jump position -2 times. So for that I'll write a for loop, int I is equal to, let's say 1, and it's less than equal to position -2, and then I plus plus. In this case what I would do is temp goes to or temp is equal to temps next, because we are trying to jump. Okay, so this is what we have till now. Now at some point, if the temp goes beyond the range of, what do we say, beyond the range of the elements, we have to return, right? So if temp is equal to null, or if just not temp, in that case you return. And additionally you need to add another statement in this condition itself, that temp and temp. So if temp is null, you break out, or if it is not, what do we say, if it is not within range, then we get out, which is okay. So by that I mean, if our position is within range, nothing would happen. If it is outside of the range, we would just get out of this for loop. Another thing is that, okay, so if I'm saying if temp becomes null, so we get out of this. Or the other thing is, if temps next is null, what does that mean? Or temps next is null. Okay, so either temp is null or temps next is null. So if temp is null, we are at a null node, we cannot delete anything, because what this for loop is actually doing is going to the node which is just before the node that we have to delete. That is the idea, right? We are deleting at position 1, we are returning if there is no node, and we are jumping position -2 times so that we are able to reach the node position -1, and through which I can access the next pointer to delete that node. So if temp is null, nothing to be done. If temps next is null, again, nothing to be done. So in that case we return. Otherwise, position -2 So we are at the node. So temp is at the node whose next node is the node that we have to delete. So for that, I'll store that next node. So let's write another node star next node is equal to temps next, or a better name could be to delete. The node to delete is the temps next node. Now I need to reassign the links, right? So first I need to have temps next, which is actually pointing to the node to be deleted, should point to temps next next. And at this place, you can just replace this with to delete as well. It's one and the same thing, but you get the idea. So we are trying to relink the left part of the node and the right part of the node, or left side of the list and the right side of the list. And after that, I just need to delete this node that we have to delete. And in the end, you just return. Now the thing is, we know for sure that if we are performing these statements, the head would not be changed. Head would be only changed when the position is 1, right? Exactly. Position is 1, we delete. Okay, so that is the code, and let's just save this and let's try to run this in our main function to test if this is actually working. So first of all, I'll just print what is already there. So g++ main.cpp linklist.cpp and compile. So we have a.exe, and if you're on Linux, a.out. So if I run this, this is what I am trying to get, or this is what I am getting. Now what I'm trying to get is the node or the linked list after deletion. So l.delete at position, and let's say what position should I give this? Let's say let's remove the number or delete the number at position 5, and let's start this count by 1 and it goes till 10. So the fifth element is having the value 5 itself. So it would be easy to see this on the terminal print. Okay, so let's just compile this and run this. So you see, by deleting the fifth node, we are not having the node 5 in this anymore. Let's try to do 10. Let's try to delete 10, the last element, if this is working on that or not. Okay, it works on the last element. Let's try to delete the first element, and let's do this again. So these are the things where you might have a confusion, or this could be treated as edge cases. So the first node, the last node, somewhere in the middle. Okay, now what if I give it -1? In that case, nothing should happen, nor should it give any error, right? So the list is same. And let's say if I give a number which is extremely big, in that case as well, the value is exactly the same of the linked list. So that is about deleting at position. And let's say if you had to delete using a value, right? If you had to delete using a value, you can change this to value, and you can just remove this condition and you check if, rather than checking position is equal to 1, here you check if the value stored at head is equal to that value. In that case, you perform this delete operation, then you return. So this would technically delete the very first appearance of that value. Next is this condition, right? Rather than having position -2, I is less than equal to position -2, you do this while the temp's next node's value is not equal to the key that you have to delete, and then you keep jumping. And yep, otherwise everything would remain same, and that's it. So what I would like is, if you are watching this and using different programming language, be sure to give the code in the description below. I'll pin it, or I will give you the credits. So that's it about the video, and I'll see you in the next one.